All right, well, that tells you one thing. So far we've got about 25 people on Zoom, so we're doing pretty good on that. Um, Thank you all for being here. This is our first post-Helene public program, and we kind of forget how to do things when there's a gap, but I think we've got a wonderful turnout. My name's Mayo Taylor. I'm the president of the Blue Ridge Naturalist Network, and I always like to start out by saying how much we appreciate that we have the use of this facility. And it's provided at no cost with a lot of support. They advertise our events. How many of you are here primarily because you're Ollie people rather than BRNN? Yeah, so I mean, it really makes it worthwhile for us to put in the effort to do these programs to get a lot of turnout. And in addition, they give us these wonderful technical students. So hidden up in the sky is Janaki, our student for the night, and we're always grateful to have them. I've been asked to make one building announcement. It will almost certainly not happen, but apparently, should the power go out, the emergency lights are not working. So we have somebody out here just for the purpose of dealing with it if that happens, and you're asked to please stay in your seats until she flips a switch, and then everybody would go out the middle door back here. So again, there's no wind or anything tonight, so I can't think we're in danger. We've kind of beaten this piece of news to death, but if you haven't done it, you need a parking pass, a daily free parking pass. And if you haven't done it yet, there's both a QR code and Diane Mooney, who's our communications person. She will communicate with you about how to get that parking pass. So, but I think most people kind of know it now. As I said, this is our first program in 2025. We will be doing a second program in April. It'll be the second Tuesday again, that's the 8th. And it will be Pam Torlina, who was scheduled to speak the week after Helene hit, and of course wasn't able to do it. She is with Conserving Carolina, which is an absolutely phenomenal local conservancy. And at that time, she was going to mostly talk about sweet things like trails to go on and all the wonderful work they're doing. And she will still be doing that, but it'll be a little different focus. And she will be able to answer a lot of questions about what's open and what's not open and what the status of things are, what projects they have going. So that's April 8th. We are so busy. You're going to hear from Paul Fredrickson here in a minute about all of the hikes that we are getting together and some other outdoor events. And so we won't be holding these programs through the warm months. We'll have them again in the fall. We've got a couple lined up already, and you'll get information on those. But we hope you will join us for our April program. It should be really interesting. Now, one date I want to get on to your radar is that we are again doing our Mother's Day plant sale, and the godmother of the plant sale is just sitting down there. And she's also the godmother of our organization because she's the reason that we have a pretty nice bank account and we've been able to support some other organizations. So it's Mother's Day, and a few of us have brought some pots. If you have any interest, the way this works for those of you that haven't done it before is you bring plants that you have potted up out of your garden, primarily native. We allow a few others, and then you swap for something that somebody else brought. And then if you didn't plant any plants, you can come and simply buy. And a lot of the motive for this is making it affordable. Our plants are priced at a good spot, and it makes it affordable for people, particularly newcomers to native gardening, to get started without risking too much of their investment income to do it. It is Mother's Day, and that is May 11th. And it's at Charlotte's house in Montford, and the time is 9 to 2. And you'll be seeing this. If anybody is not on our newsletter, you should have just gotten one at the first of the month. If you're not getting our newsletter, there's a sign-up sheet here by Diane right behind my computer. And then that gets you on our newsletter. It doesn't make you a member, but you'll get all the news about everything we do and know what's going on. We really need plants this year. If you are a native gardener and you have some that can tolerate being divided and potted up, obviously some of us pot a lot in the fall. That didn't happen so much this year. And some of our yards are damaged, and one of our most important contributors moved far, far away and won't be bringing any plants. So please be in touch. And if you would like to get some pots tonight, Penelope, stand up. And she's brought some big ones. I've got some smaller ones out in my car. If anybody thinks that they want to get into the business of dividing native plants and need some pots, we brought some tonight. And the plants need to get into the pots in the coming weeks in order for them to be ready by Mother's Day. So, is that good? Yeah. The plants don't care. Okay. Thank you, Charlotte. Okay. Some of you are likely past members. Some of you are perhaps current members. Should you want to renew your membership tonight, we have membership forms back here, and Chris, stand up. Chris Stewart is our treasurer and membership person, so she handles both ends of the transaction, keeps your record, and takes your money. If you want to join tonight, that's also possible. If you want to join online, it's real easy on our website. And you go in through PayPal, but you don't have to have a PayPal account. So if you need to renew, go ahead and do it. Our hikes are going to start up soon. Our hikes are just for members. That's a hint. And if you want to join as a new member tonight, we'd be glad to have you, or online. All right. I think I've handled almost everything. So I'm going to turn it over to Paul Fredrickson, who's going to tell you about our coming many, many outdoor outings that he has planned, and then we'll get to our speaker.
Thanks, Mayo, and welcome. Well, some things happened in 2024, didn't they? And we've had to rethink some of our hikes this year. Melrose Falls is gone. Craven Gap is gone. We've also lost Big Creek. Big Creek is no longer accessible. So we've had to reposition things and add new hikes and new events to our calendar. I'd urge you, if you want to go out and see all of them, you can go to our website, brnnetwork.org, and we have a calendar out there with all of the hikes listed there. So have a look at it. A couple of points now of the upcoming hikes. First of all, we're going to be looking the end of this month, March 27th, we're planning on going to Bell Park. Bell Park is a brand new park. It was opened in November. It was basically created by Conserving Carolina through a property donation. It's between Saluda and Hendersonville. I was out there this last weekend. It's a beautiful place. It's a nice hike in the woods. We don't know what the wildflowers are. It was open in November, so what do we know? Anyhow, it'll be a nice time for discovery, a botanical discovery. There is some up and down. They say elevation change of 200 some feet. The nice thing is there are very, very few rocks and roots. I mean, we see a lot of that in Pisgah. We don't see that here at this location. So that'll be March 27th. April 2nd, we're planning on going to Station Cove, which is down in South Carolina. We were there 2 years ago. An absolutely beautiful place. It's about a little over an hour, hour and a half maybe to get there, but well worth the drive. I was there over the weekend as well, and I was surrounded by trilliums. Yes, trilliums are up in abundance there. We saw the toadshade trillium, if you're familiar with the toadshade trillium, the Cuneiana. Beautiful. We're also probably going to see some bloodroot, and there's a beautiful waterfall at the end where we'll probably have lunch. So I'd urge you to sign up for Station Code. That'll be April 2nd. A couple of other ones real quick. Pink Beds, we're going to go there on April 8th, and Gary Kaufman will be leading our hike. Gary Kaufman, some of you may know Gary Kaufman. I think he's worked with the Forest Service. He's led a number of hikes for us, and I'd urge you to sign up for that one. We will have a limitation on that, I think. We're not going to limit Station Cove. We're not going to limit Bell Park. And then after that, we're going to look at going to Rocky Fork. Some of you may know Rocky Fork. It's a beautiful park in Tennessee, just over the border, a gorgeous place. And we're going to be led by a ranger, Jeff Sweeney. And he's going to be showing us wildflowers in Rocky Fork. Be a beautiful place. By the way, some of these have been impacted by the hurricane, but all the trails have been cleaned up and they're all in good shape. So we'll not have a problem with those. Other things that are going to be happening through the rest of the year, through the rest of the events, I guess. We have 2 birding events coming up. It was a request from at the annual meeting. We have 2 birding events. One is going to be in Sandy Mush, thank you, Sandy Mush, and the other one in Waynesville. And so that's going to be fun to go out there and see some birds. And May 20th, our speaker, Bill Jacobs, will be leading us on a hike in High Falls on the Tuckasegee. And Bill will be talking about a little bit about that today.
I'll say a little bit about it. Yeah.
And by the way, Bill does have some books, and in his book, he covers, 2 or 3 pages on the High Falls on the Tuckasegee and the importance of that relative to geological.
Yeah, it's that reflects that it's a pretty fascinating place geologically.
Oh, and by the way, there are beautiful wildflowers there too. Us on that side. Also, we're going to be going back to Pisgah View. If you haven't been there, I'd urge you to go out there, one of the new parks. And also, Ron Lance will be taking us to Ashmore Heritage Preserve. Ron is a great leader. He's done a lot of events around the area. He's spoken at a lot of plant conferences, and he's written 2 books. One is a definitive book on hawthorns. Unbelievable. Anyhow, that's all I have. Any questions on the outdoor events? Okay, again, we have them on the website, and they will be, we have the Bell Park going out in a couple of weeks. No, next week, announcing it and just having people sign up, just sign up and register. And then we'll be sending out the email for Station Cove the following week. So if you make sure you're on the mailing list. Okay, thank you.
All right, well, I'm going to introduce our speaker now. Just a couple things. We have 50 people on Zoom now. And one of the aspects of having them on Zoom is they can't hear anything that isn't put into one of these microphones. So we're going to ask that most questions be held until the end. And we will have 2 people that have microphones and you need to speak into the microphone. If a question does come up and Bill takes it, I'd ask you to
I'll repeat it
so that the people on Zoom can hear it. And then those of you who are on Zoom are very glad to have you here, and you can put your questions in chat and then I will convey them up to Bill. And as we mentioned, he does have some of his books here, and I'm going to mention that in a minute, and he will be able to sell them to you after the event if you would like to. So Bill Jacobs is like a lot of us who are active in the Blue Ridge Naturalist Network, in that he had a career that didn't have anything to do with this. He was an attorney. I'm sure it was on the good side of things in Atlanta. So his career was not related to geology, but once he retired, he started a very concentrated pursuit of knowledge of the natural world through courses that he took, variety of courses, self-study, and of course, on-the-ground experience. His deepest interest was in geology, and specifically the geology of this region. He's likely known to some of you as the author of Whence, These Special Places, the geology of Cashiers, Highlands, and Panthertown Valley. But tonight he's going to include some focus on some things that are a little closer. And another thing to know is that in the course of doing all this, he became a book publisher as well. So he puts out his own book and others. So turning it over to Bill Jacobs.
Thank you, Mayor. Yeah. It's really a pleasure and an honor to be here with this group and on this campus. A lot of connections. My first live geology course was actually out at the Arboretum, Steve Yurkovich back in the day. I didn't pursue the naturalist certification a lot further, but I took several courses out there. And I later took a number of courses here at UNCA in the Earth Sciences offerings, which led to a number of interesting connections. In addition to being great courses, one of them was that I ended up working with several of the faculty members here on an interesting research project, which we have subsequently published, and I'll talk a little bit about that as we get into this. Another is that as a registered student, I had access to the university's media design lab, which just happened to have the computers, software, and technical support that I discovered that I really needed if I was going to get this book published. Laying this out was not easy. Those of you who've been looking at it realize there are a lot of pictures, there are sidebars, there are double columns and things like that. Word wasn't going to get the job done. So I was very privileged to be able to spend a lot of hours in the basement of the library building where the media design lab is. The title of tonight that we've written is The Geology of the Blue Ridge, its waterfalls and its mountains. That's a little general, actually. Geology could cover a lot. It doesn't really convey what has been the focus of my interest and the focus of what I want to talk about tonight. And that is, what are the processes that have made the things that we see around this region that are so important to us, the beautiful places like these? Why do they look the way they do? What is it in the geologic history? Actually, the title of my book conveys that a lot better than the title that I used for this talk. Whence, from what place, source, or cause do we get these places that we consider so special? While I got the book up, I will point out that true to the subtitle, there's a lot of focus on the Highlands Cashiers Plateau, which is where we lived for 10 years and which really got me intrigued with geology, got me into all this. But the books, the geologic history really applies equally well to all over the Eastern Blue Ridge, including right here. And it also includes specific discussions, as some of you who've been looking at it probably realize, of places that aren't on the plateau. Some of the surrounding features, like Looking Glass Mountain and the escarpment and some of those waterfalls. So I like to work into this topic of whence all these special places by making a couple of observations that, after you think about them, are pretty obvious. But I think they help frame the inquiry that we'll be trying to do over the next 45 minutes or so. Some of our mountains, like Looking Glass, are smoothly rounded. But, 5 or 6 miles as the crow goes to the northwest, you have Devil's Courthouse. Totally different type of rock formation and form. Craggy, rough, uneven. Sliding Rock, right there at the base of Looking Glass, well, it's smooth enough to slide on. Go downstream a couple of miles, and you get Looking Glass Falls. Totally different kind of falls. It lost my pointer here. There we go. Abrupt drop. You can't really see it in the picture, but this is a recess. And back in there are these rough slabs, upturned slabs of rock. So just a totally different kind of feature. And these differences that I've just highlighted in these two cases reflect that in this Eastern Blue Ridge, we have two very different rock families. You can keep up with the number 2, you can keep up with the rock families that we have. Now, some of them are kind of complex, so it's not quite as simple as 2, but those two different families have very different geologic history, and as a result, they react very differently to the forces of erosion and weathering as they have come to the surface. And that produces these dramatic differences that we have in our rock formations. And that's what I'm going to explore in some detail. And hopefully you'll get a good feel for how that has worked. And I think as you visit places that we talk about, understanding this background, at least it has for me, really just adds another dimension to the natural world that I'm exploring. So these two families, one is called the country rock. That's the rock that was here first. It was the rock that formed the country into which the second family, the Plutons, later intruded. Well, those are our two families. As I said, they have very different geologic histories. We'll start with the country rock. It got here first. Why do we have it? Where did it come from? Well, first thing, the key fact to remember about the country rock is it sure didn't form up here. Didn't even form on dry land. It formed several hundred miles to what is now our southeast in an ocean. It was underwater. Now, I think this graphic, just courtesy of the U.S. Geological Survey, helps explain what was going on. This was about 550 million years ago that our country rock was forming. And 550 million years ago, you had a continental area, the predecessor of North America, with an ocean off the coast, like we have today. And as was the case with any continental mass and land basin, rivers are carrying sediment off that continental mass. And back then, remember, this predated vegetation. So there wasn't anything to hold the soil once it weathered. So massive quantities of sediment, all different kinds, mud, sand, fine-grained sediment, various minerals was being eroded away, washed down these rivers, and deposited on this seafloor. Other stuff was being added by a line of volcanoes, volcanic islands that were standing off what is now the southeast coast of North America. That was spewing out ash, lava, and that got mixed into the stuff that was accumulating. As it accumulated deeply, miles deep, the weight of the overlying sediments squeezed the excess water out of the stuff below. Minerals that remained in what little water was still in there would precipitate out. They glued all those sediments together and they became rocks. Sedimentary rocks is appropriately named. Exactly the same sediments that had washed down those rivers or blown out of those volcanoes, but glued together as a rock. Now, those aren't the rocks we see today, but I call them the parent rocks. These are the rocks that eventually become the rocks that you can see all around campus and all around Asheville, all up and down the Blue Ridge Parkway. But there's a lot of work to do to get them out of the ocean, up here, and converted into the kind of rocks we see today. And that's what these blue arrows are about. Those are indicating plates, tectonic plates, Earth's crust, that are coming at each other. This is the whole phenomenon of plate tectonics. The Earth's outer rigid crust is divided into 8 major plates and a dozen or so minor plates that are rigid but can move about relative to each other on a more viscous lower level of the Earth. It's not liquid, it's more like peanut butter, but it does enable these land masses to move around slowly. Think of the speed your fingernails grow, or your hair would be a high-speed plate. You're talking about an inch to a half a foot a year sort of movement. But you continue that for hundreds of millions of years, and stuff moves a long ways. All right, so back in the day, 550 million years ago, this plate out here, and what we would call the Atlantic Ocean today, Africa is way over here. It's moving towards North America. And the stuff that's between Africa and North America is getting pushed up onto the continental mass that becomes North America. It wasn't called that back then. And know what's happening as these volcano islands are getting pushed in, they are scraping rocks up off the floor of that ocean and pushing them towards the landmass. Fast forward 100 million years, and this is roughly what things look like. Those rocks that had been on the bottom of the ocean floor have been pushed up on land, and big mountains have grown on top of them as other stuff has been pushed up behind them. And so big, probably rocky-ish type size. It's not up here. This is a couple hundred miles off to the east still. But they were large mountains. A lot of stuff got piled up on top of our parent rocks, which were buried up to 20 miles at that point. At that depth, the heat, the pressure transforms them into different rock. Minerals rearrange themselves, some new minerals get formed, and the result is they metamorphose. They become metamorphic rocks. Those are the rocks you see on the ground out here today. Now, there's were still in the wrong place. They had to be pushed on up a couple hundred miles from the southeast. That took another 150 million years, at the end of which Africa had joined, slammed into the east coast of what is today North America, and in the process had pushed out a truly enormous range of mountains, Himalayan in scale and a couple of thousand miles long. But that mountain range was probably focused more in the upper Piedmont. It wasn't up here. Our rocks, as that pushing was occurring, a large slab that geologists call the Blue Ridge Piedmont mega thrust sheet. There's a big sheet of rock, measured in hundreds of miles lengthwise, broke loose and was transported inland for 150, 200 miles. That left it here. That's how those rocks got here. So at this point, they've been metamorphosed, they've been moved, they're in the right place, they're buried miles down, but another 100 million years or so of erosion, and they're at the surface. They're what we see today, all determined by what went on beginning about 550 million years ago. Now, the takeaway from all that I hope you'll keep in mind for the purpose of this talk is to realize that our country rock was formed from this wide variety of sediments. They'd been chaotically layered, they'd been mixed, they'd been pushed around, heated, pressurized, twisted, turned for hundreds of millions of years. What do you think that produces? Well, you ought to expect a lot of variety out of that. And that's exactly what you get. This will look familiar to anybody that's visited the Arboretum. That's the road cut at the entrance to the Arboretum. Just all those different colors and textures and what have you that you see in that just bespeaks of the variety that we have in our ash metamorphic. It is called the ash metamorphic suite, by the way, ash for Ashe County, where it was first studied in North Carolina. Metamorphic for obvious reasons, and suite because it's such an array of different rocks, all formed in basically the same methods. But all of the rocks up at this end, from the light ones to the dark ones to the middle ones, and I don't have any, I should have some muddy ones because there are plenty of those. All of these rocks at this end of the table, and I encourage you to come up here and look later, are part of this ash metamorphic suite. That's one thing that makes it a lot more complicated than the number 2, because one of those ones has a lot of different rocks. This is an image that I particularly like for illustrating the diversity of the ash metamorphic suite. This is on the south face of Whiteside Mountain. There's a climber there in the middle to give you some scale. Every rock in that image, from the lightest to the darkest, was part of this ash metamorphic suite. Another reason I like this image is that it really, I think, bespeaks of the power and the forces and the temperatures that have been involved in this formation process. The way this and this black stuff, you probably guessed, this would have been sourced in those volcanoes. But these volcanic rocks have been just twisted around, intertwined with these other rocks that would have, this, for example, would have been muddy sand accumulating at the bottom of the ocean. This would have been cleaner sand that had accumulated. But they've all been twisted together And then these white streaks through here are where light-colored rocks, the feldspars and the granites like this, had melted and sort of oozed through the rest of it. So just a tremendous amount of force and turmoil going on. Now, at the far opposite end of the color scheme from some of these volcanic rocks is shining rock. Many of you been out to Shining Rock? We had a few. Those who've been there know that the all this gray stuff in these pictures is either shadow or lichen. This is the color of that rock, all of it. A little bit of mineral staining here and there. And you also, if you looked at it closely, would realize it's very different. It's quartz. This is quartz. Those are two very different quartzes. This one's big crystals. You are hard pressed to make out crystals in this one with your naked eye. Very tiny grains and a huge quantity of it. I mean, Shining Rock goes on for over 1,000 feet. Depths, tops out at 70 or 80 feet high, but the top of the mountain is a couple of 100 feet higher elevation than the lowest exposed, and who knows how far down in it goes. Now, interesting thing, at least I think so, this white is the product of a bunch of crystals that are exactly the same color as this rougher quartz, which is the normal quartz you would see when you're hiking around in our mountains. You'll see veins of quartz in all kind of rocks. And they're going to be large grain, kind of, gray and brownish sort of stuff. This is really unique. There's only one other place in Western North Carolina or anywhere else in the world that we've been able to find literature. And whereas this stuff is very common. Why does this look white? Well, I call it optical white. It's not pigment white. It's not the pigment in somebody's shirt, for example. All those tiny little grains arranged tightly, reflecting light in all kind of random directions, result in the light that reaches your eye from this rock is catching all the bandwidths of light. They're all being scattered about so that the sum that you get to your eye is all the bandwidths, which means you see white, which is, of course, all the visible bandwidths of the combination of all the bandwidths of visible light. This begged in my mind, where did this come from? First time I saw it, I said, this is different than what I was expecting. I Googled it and nothing, never been written about. So it actually triggered, I was taking a mineralogy course at the time. I got my mineralogy teacher, faculty member interested in it. And we did a study on it, research piece, which we, a couple of years ago, was published in the journal of called Southeastern Geology. We concluded, by the way, and you can read more about this if you're interested to get more detail, both in the book and more definitively in a write-up that's on the website for the book. greatrockpress.com. I will need to, I have a section in there on research and resources, and I've written up a piece about Shining Rock in more detail and with more information than I had for the book. Now, this was the paper that we ended up publishing. That title is kind of wordy. I would have preferred something like Whence, Shining Rock, but the requirements of academic writing prevailed, so that's what we came up with. Okay, back to our ash metamorphic suite. We've talked about the tremendous variety. This rock, you would also expect it, and it does, have a strong tendency for ragged surfaces. There's a lot of internal layering, a lot of weaknesses. It's been pushed around a lot, twisted, turned, metamorphosed. So the layers can be at any angle to today's surface and often to each other. And there are a lot of these internal weaknesses that create fractures. Typical exposures, like at the summit of Craggy Pinnacle, you'll notice these sort of upwardly tilted layers of rock that tilted out up over the visitor center there. Or some of you may recognize this one. This is a trail. These are these upright fins of rock. The rock had been turned totally on its side here. See that over here? That's a glove I threw down as a poor attempt to provide some scale. That's your clue as to where this is. That's a corner of the transmission tower at the top of Mount Pisgah. The types of mountains that you tend to get out of the ash are going to be jagged and pointy. And let me say, everything has exceptions. The Earth's incredibly complex, but these general rules really do help a lot and tell you a lot in most cases. Having those layers at various angles generates some irregular and often steep points on your mountains. On your waterfalls, ragged, busy surfaces. Here, Pearson's Falls, you see all these layers, and they're tilted down a little bit. As a result, you get this stepwise sort of surface. Okay, we'll see some other illustrations later, but we need to turn to the plutons, that other rock family. What is a pluton? A pluton is magma, stuff that if it gets to the surface you call lava, that doesn't make it to the surface. It gets trapped down in the country rock. As a result, it slowly cools, and typically around here, the chemistry is such that it's going to become the rock we call granite. It's much more made from a much more homogeneous mass of magma. And it hadn't been around as long. It hasn't gotten pushed around and metamorphosed as heavily. As a result, it has less internal weaknesses, less fracturing. But rock has to fracture. Now, why is that? Well, this stuff started out miles and miles underground under incredible pressure. As it's come to the surface, that pressure has been removed and it expands. Not a lot, but you don't have to, rock doesn't have to expand a whole lot to need to have some fracturing to accommodate it. Well, the ash metamorphic, that's no particular problem. It's got all these weaknesses created by layers and all in its history. But The pluton is a tougher nut, and what it tends to do is to sort of onion skin, pop off layers. It's called exfoliation. As a result, it weathers more smoothly with a tendency to create rounded surfaces and retain the original shape. Exfoliation, I think, is nicely illustrated with this, which is at Stone Mountain, which is out on the other side of Linville Gorge, where you can see these slabs that have sort of popped loose, basically parallel to the surface. And they, over time, will weather and erode away. This can occur at all kinds of scales. There are others that are a centimeter or so thick. And just sort of, it's a lot of, can vary, but it's a continuous process. It's happening now. And over time, it will wear these down. But in the meantime, it gives them a rounded, smooth surface. The other thing about this characteristic of the pluton, without those deeper fractures, frequent fractures, water doesn't get in. And water getting into a rock is a big deal. It brings in environmental acids, soils form, life forms, water gets in, freeze, thaw. Rocks break down a whole lot faster once water can get in. So even though a lot of this is some of the pluton made of exactly the same stuff as some of this ash metamorphic. Quartz, feldspar, mica is predominant. The ash, because of all the fracturing, erodes away a lot faster, much more vulnerable. The plutons tend to be longer lived. Some of the typical pluton exposures, this is one over near Cashiers. Little Bear Falls, just classic pluton waterfall. Toxaway Falls, you can see that from the highway up on going towards Lake Toxaway. See so much of that because the dam burst in the 1916, scoured things going down the valley. Over in Panthertown, any of you get to Panthertown? You some? Yeah. You will. Some of these will probably look familiar. Both of these are very different. This is a very tall vertical. This is Granny Burrell's low angle, but they both share this rounded, relatively smooth surface, and it's all because they're pluton. Mountains, of course, Looking Glass is a classic exfoliation dome. That's the geologic technical term picking up the exfoliation process that has sort of shaped and smoothed and maintains this. And yeah, it really does contrast with some other nearby mountains. We've already talked about Devil's Courthouse, and over here is Mount Pisgah, much pointier, and it has some really ragged, if you've hiked up there, it has some ragged cliff-like rough areas as you get up to the top. This is a pair that are over near Cashiers. It's included it to a couple of reasons. One, a lot of us normal parlance who are familiar with the term pluton would say this is a pluton and the other one is a pluton. Well, actually, these are surface exposures of a much larger pluton. These are both part of what's called the Whiteside Pluton that goes for about 20 miles across the Highlands Cashiers Plateau. This is Bill Jacobs' concept of the Highlands Cashiers Plateau. Can't find an official definition. This is based basically on valley elevations being above 3,000 feet, which is 1,000 to 2,500 higher than surrounding valleys. Turns out the Highlands Cashiers Plateau is the largest concentration of plutons in Appalachians. Everything in this image that is in color is a pluton. Everything else is country rock. This one running down the middle from Highlands through Cashiers, Panthertown, Lonesome Valley is where that pair I just showed you were. Goes on all the way over to Highway 151, coming up from Rosman to, what's that? Sorry? Well, it's headed towards Canton, but this is, yeah. But it's well before you get up to the Parkway. It's still on this side. Balsam Grove, maybe. Now, this is today's topography. Come back in 10 million years, and I think erosion will have removed more of the country rock, and some of these tan areas will be filling in because this country rock is continuing to erode. It's a process. Now, why is the plateau this way? It really, I think, boils down to being in the right place 3 times. We've had 3 major mountain building events in the last billion and 1.1 billion years. And these mountain building events also produce these plutons. The most recent was about 300 million years ago when Africa was banging into the East Coast. It produced these blue ones and also Looking Glass Rock, which is about 15 miles over this way, but is part of this green one. This was back when those those volcanic islands were first coming up on shore, building those mountains about 450, 65 years ago, million years. This is the Whiteside Pluton. And this one was actually here before our country rock. Country rock got pushed up on top of it. This is the Toxaway. It goes back 1.1 billion years. And that's when the mountains that were part of this previous supercontinent called Rodinia were formed. And it's those mountains, by the way, that provided the sediments that flowed down those rivers into the ocean that became our country rock. This stuff cycles through. Now, the fact that we have these 2 families of rocks is at the heart of why we have a lot of the diversity that we have in our special places, these different kinds of rocks and mountains that I've been talking about. It gets even more interesting, though, because we also have mixed exposures. This is one where I first started figuring this out. So it's kind of near and dear to me. It's not the most spectacular. I'll show you that in a minute. But this stream down in Panthertown, Greenland Creek, about a half mile above this waterfall, you can wade it and you're on Pluton with very easy little wading, gentle stream. all of a sudden you get this 15-foot drop in a ragged waterfall. What's going on? Well, if you clamber up, bushwhack back up to the top of the falls, this is what you see. Nice, smooth Pluton. But you go under the falls, and this is what you get. This layered rock, layers tilted up, just like those at Looking Glass Falls. And that's important, because with those up-tilted layers, water gets down in between the layers, weakens the rock, freeze thaw. This stuff starts dropping off the bottom, and you get an overhang. You can actually walk behind this waterfall. So what has happened here is that the water was held in place coming across this extended length of Pluton. It got to the end of the Pluton. It got into this more vulnerable rock, and pretty quickly it cut a 15-foot waterfall. All right. So now you ask, why didn't it go farther than 15 feet? Why isn't it 50 feet? Well, there's your answer. That waterfall lands on more Pluton. No cracks, no water is flowing smoothly off, and it flows on downstream for a while till it finds another place to make a quick drop. Now, you may be realizing that, hey, Pluton here, country rock here, can I see where they meet? Well, you can. Off to the left here, the bottom is horizontal Pluton. This is the back wall of the waterfall, basically. This line right here is where they meet, and the age difference across that line is about 100 million years. This mixture also shows up in the shapes of our mountains. I love this image. It's a beautiful scene, but also you've got two sets of mountains, two pair, one in the foreground, one in the middle background. One of them's obviously, in each pair is obviously an exfoliation dome. Called Black Rock Mountain here outside Highlands. Back here, that's Rock Mountain outside Cashiers. But each of them has the partner is different. Chimney top back here wants to look like a Pluton, exfoliation dome, but there's this chimney. What's that all about? That chimney is a remaining country rock that has not yet eroded away. And as long as it's up there capping that mountain, that will determine what the peak is going to look like as it erodes. This is Whiteside. Pluton down here, but this angular, sharp, and extremely precipitous, which shows better here, which is from the valley below, peak. Below the red line, Pluton. It gets steep, really steep, but it rounds into the steepness, and it's smooth. The country rock, you can see the layering, all these pock marks and what have you, are where compositional differences have resulted in faster erosion of some of it. That arrow points to that scene earlier where the climber was in the middle. I don't know, how many of you have hiked the trail around? It's really worth your time. It is a beautiful trail. Goes right along this rim. Grand views off down the upper Chattooga Valley, down into the Piedmont. And every foot of that walk from there's a loop trail from the Forest Service parking lot is on Country Rock, but under it, and you get some great views, is the Pluton. You know, I sort of think of this as we're really blessed to have the diversity. And as in so many areas, diversity in geology is a powerful creative force. And we can see that here. We also, I think, see it here. And this is High Falls. This is the destination of the hike on May 20th. This rounded Pluton upper falls hits the shelf of Pluton and stops, but then drops over this ragged Country Rock cliff, lands in a pool that has Pluton around the edge lining, but then there's this immediately Country Rock, more Pluton, more Country Rock, Pluton up top. It doesn't really show very well. About a 30-foot recess here that doesn't show up where this Country Rock is eroded out. Just say a little bit about the hike. We're going to do something different and special here, at least different from what I've done in the past. There are two ways to get here. One is from the top, the Lake Glenville Dam, down a trail built by Duke Power as part of the deal to continue licensing Lake Glenville for power. And it's geologically quite interesting. And up at the top, I'll talk about and can show some of the where the Pluton and forms is used in forming the lake, and some of the history of that lake, and the building of this power system is pretty fascinating. And then you go down 650 vertical feet to get down here. It's on rock steps, a lot of it. That's not so bad. I mean, you know, I recommend a pole to sort of just for balance, and come in. Some of those rock steps are not real even. But it's a bit of a drag going back up. The other way to get in is from Highway 107 downstream. It's longer. It's a 2 or 3 mile hike in instead of a half-mile hike in, but it's not nearly as severe in either direction. And you see another nice waterfall as you go. And May 20th is getting a little late for wildflowers, but it is it goes over some spectacular wildflower country. So we're going to start at the top, come out from the bottom, and do a shuttle. We'll have to, you know, shuttle cars, but I think it'll make a special time. There is rock clambering involved. I mean, you know, you have to sort of jump across these rocks to get from the steps over here and to continue. If you're really energetic and adventurous, you can climb up here. But there's a lot to see, and it's a great place to have lunch. Now, I need to finish up here. You might be thinking, all this stuff is just intertwined with each other. The Pluton and Country Rock. You know, that doesn't fit very well with this idea of a Pluton that you showed. You know, this bulb of magma that's just kind of down there in the Country Rock. You're right, it doesn't. Well, if your model doesn't really fit the facts on the ground, it's time to work on the model. I mean, this is a great device just for getting the idea. I developed this as a more realistic, I suppose, but still quite inaccurate, or non-representational model. And keep in mind that this magma is under pressure, it's very hot, and is pushing into a rock that has lots of internal weaknesses, and it's taking advantage of everything it can find, and it produces these extremely complex interactions between the two rocks, particularly at the edges of the pluton, and which is exactly where High Falls is located. Now, I can spend a little bit of time talking about, I really haven't been telling you why we have mountains. I've been telling you why a lot of rocks look the way they do, but that's really not the same question. I can spend a little time talking about that, or we can go ahead and do questions. I'm not sure when we need to stop. I can talk this, and then would we have a little time for questions after that? Okay, yeah. All right, you say, okay, Bill, you told us there have been 3 major mountain building events, and 2 of them in the last 500 million years or so. What's the big deal? Well, this was the one about 450 or so, 500. I showed you that earlier. If these mountain building events were the source of the fact that we are higher elevation than the Piedmont, then they would be the world's oldest mountains, and nothing else in the world that comes close. Well, that's the problem. There's nothing else in the world that comes close because mountains don't last that long. Even the Himalayas are expected to be a Piedmont in about 100 million years. Our most recent mountain building event, which was actually down in upstate South Carolina, was 300 million years. So how can we still have them? So in the last couple of decades, geologists have started thinking about this more and looking at it more. And I think most are coming around to the idea that something else is involved, and that one likely something has picked us back up in the last 5 to 20 million years. Nobody's real sure when. What is the evidence that, and I'm talking to not just here, but the entire Appalachian system, including the Cumberland Plateau, all the way over to the escarpment. What is some of the evidence of that? Well, I mean, one thing is exactly what we've got. We still have this steep topography. We have these mountains. We got V-shaped valleys. That's a young landscape, not an old landscape that you're describing. Stuff hasn't rounded out. We also have these sinuous river gorges. That's the Tuckasegee, which is the river that High Falls comes over, actually. Corner to corner in this is about 12 miles. The river in red is about 16 or 17. And in that time, it makes a dozen hairpins. And look how it cuts through some of these ridges. How does that happen? That's not the way rivers coming down out of mountains are going to do. I mean, what this is saying is that the river was located where it was, and the land started rising. It was trapped in its course. And as the land rose, it just kind of dug in deeper. And then that land, as it rose off to the side, has been eroding ever since it started rising, and has created this higher elevation topography that we have. That river probably looks fairly similar to this. That's the lower Mississippi. And it's got all that same sinuosity. That's what rivers do in a flat landscape. You can also see that in the Colorado River, which formed, cut down through a flat landscape and got trapped in its canyon. So, and there are other studies that have traced the upstream movement of today's waterfalls and looking at surges in sedimentation downstream. I mean, it seems strange, but you go out on the coastal plain and do geology about the mountains, because that's where the mountains end up. And you can time, when did this surge of sedimentation that formed these rocks come down? And there are these significant surges in the last 5 to 20 million years. So, it's, there's something going on in the mantle. It's not plate tectonics, at least not directly. There are some, I think, some valid, good hypotheses that I'm not, unless asked in question time, I'm not going to get into as to what's going on. But it's very hard to study what's going on in the mantle. The only way it can be studied is through seismic studies and basically whole Earth computerized tomography. They look at the speed of the seismic waves are going through various locations in the mantle. The hotter it is, the slower the speed. Colder, the faster. And very powerful computers put massive amounts of data together and come up with maps of the interior that can support this. I like to think that while it's always great to say, hey, we have the oldest mountains in the world, it's really a lot more interesting to me to think of it as these ancient geologic processes that I talked about have determined the nature of our rocks. They've set them up with the potential to become our modern landscape and to become the places that we consider special. But it took much younger geologic processes to actually bring them up higher into the surface, to unlock that potential through this rejuvenated elevation. And with that, I will mention that I do have the book for sale. I can take credit cards. If you're out there on Zoom and are interested, please go to www.greatrockpress.com. You can order it. It'll come from me at that. And that's also where you can find these additional resources. Well, I would be delighted to respond to any questions or comments that you might have. It's been a lot. You've been a great audience. Appreciate your patience and your attention. Yeah. No, thank you. Yeah. Charlotte? Yeah. Oh, yeah. You've got it.
One from our Zoom group. There's one of our viewers said that they studied geology in the 60s, and they had never heard the terms country rock and Pluton, and were wondering if these were relatively new concepts.
I don't think those are particularly new. What is new, if you studied it in the 60s, you would not have heard much about plate tectonics. That only became accepted in the mid and late 60s and totally transformed geology, transformed a lot of other fields too, yeah, a lot of the natural sciences. Yeah. Over here, yeah. No.
Hi, that last section you talked about, the rejuvenation uplift, I'm probably pushing the envelope here of what we know, but very roughly, what amount of uplift at the surface are you talking about? I mean, how many feet?
Oh, well, you have to sort of take a guess at. I mean, I think that it probably is reflected by the amount that the higher portions of today's mountains are above the surrounding non-Appalachian areas, which is 3,000 or 4,000 feet typically. It may be higher because we're not sure when all that happened and how many tens of millions of years erosion has been going on. So there's some uncertainty about it. But I think for it to make sense, it would have to be in in a 3, 4, 5,000 sort of foot uplift to give you a high point that's at like 6,000 feet. Hmm? Oh, earthquakes? Well, I don't think it's still, the question was, what about the earthquakes? Yeah. We do have earthquakes. We don't have big ones. They are probably, they may have, this uplift is not known to be going on now, though it's probably not causing current issues. But the Earth is continuing to adjust, obviously, to the huge amount of that stuff has moved around over geologic history. Also, we feel the East has much more of a bedrock base, stiff bedrock, covers large territories than you have in the West. And as a result, our earthquakes travel a lot farther. So we get affected by stuff that can happen Charleston easily, St. Louis, that are scattered around. So, but that said, there's still a lot of small earthquakes that occur around about Appalachia. And exactly what the Earth is responding to there, I don't think anybody really knows. But there's no threat, we think, of a big one. And, it's not that sort of setting. Yeah, Paul.
I had heard that, or read, I think, that the Grand Canyon is a result of an uplift.
Yeah.
Are you familiar with? Okay.
Yeah.
So
Yes.
kind of the same thing that you're talking about in terms of.
Yes, although in that case, it's thought to be a little different. The river in its present course did not form until after the uplift.
Okay.
But it did erode down through a level, basically a level surface, not coming down out of a mountainous surface.
Thank you.
But it was a sort of a lift of the general area.
So back to the uplift here, were you saying it didn't happen in the Piedmonts and the escarpment and it's just happening kind of west of those?
What is that? The uplift?
The uplift.
Well, it depends on how far the escarpment has receded since all this started. But the extent, obviously there's a big difference between what has happened in the Piedmont and what has happened up here. So I would think that the boundary has to be somewhere along what we now view as the escarpment, maybe a little farther out. Okay, right, yeah. That all? Yeah, thank you. All right, and feel free to come up and check out the rocks and ask more questions. And
Remember our program next month, April 8th, 7 o'clock, same place, and it'll be all about conserving Carolina and what they're up to right now.